Your experience with things that you have seen before is inadequate, is incomplete. The behavior of things on a very tiny scale is simply different. They do not behave just like particles. They do not behave just like waves. Atoms do not behave like weights hanging on a spring and oscillating, nor do they behave like miniature representations of the solar system with little planets going around in orbit, nor does it appear to be somewhat like a cloud or fog of some sort surrounding the nucleus. It behaves like nothing that you've seen before. Well, there's one simplification. At least electrons behave exactly the same in this respect as photons. That is, they're both screwy, but in exactly the same way. How they behave, therefore, takes a great deal of imagination to appreciate, because we're going to describe something which is different than anything you know about. This, in that respect at least, makes this perhaps the most difficult lecture of the series, in the sense that it's abstract, in the sense that it is not close to experience. And I cannot avoid that. Were I to give a series of lectures on the character of physical law, and to leave out from this series the description of the actual behavior of particles on a small scale, I would certainly not be doing the job, because this thing is completely characteristic of all of the particles of nature and is a universal character. And it is, if you want to hear about the character of physical law, essential to talk about this particular aspect. So it will be difficult. But the difficulty really is psychological and exists in the perpetual torment that results from your saying to yourself, but how can it be like that? Which really is a reflection of an uncontrolled, but I say utterly vain, desire to see it in terms of some analogy with something familiar. I will not describe it in terms of an analogy with something familiar. I'll simply describe it. There was a time when the newspaper said that only 12 men understood the theory of relativity. I don't believe there ever was such a time. There might have been a time when only one man did, because he's the only guy who caught on before he wrote his paper. But after people read the paper, a lot of people kind of understood the theory of relativity in some way or other. But more than 12. On the other hand, I think I can safely say that nobody understands quantum mechanics. Now, if you appreciate this and don't take the lecture too seriously, that you really have to understand in terms of some model what I'm going to describe, and just relax and enjoy it, I'm going to tell you what nature behaves like, and if you will simply admit that maybe she does behave like this, you will find her a delightful, entrancing thing. So that's the way to look at the lecture, not to try to understand. Well, you have to understand in English, of course. But in any sense, in terms of something else, don't keep saying to yourself, if you can possibly avoid it, but how can it be like that? Because you'll get down a drain, you'll get down into a blind alley in which nobody has yet escaped. Nobody knows how it can be like that.